Hello and welcome to Math with Mrs. Becker. Today in College Algebra, we are going to look at section 7.5, where we get to perform operations using matrices. Okay, the first thing is looking at matrix addition and subtraction. You can add or subtract two matrices, and in fact, you can do this with 3, 4, any amount of matrices, if and only if they have the same dimensions. Okay, there's that dimensions thing. You have to know the dimensions of the matrices. You can only add and subtract them if those dimensions match. To perform the operation, add or subtract the corresponding entries. So let's go ahead and just do an example. Remember, when you're doing dimensions, it's horizontal by vertical. So A would be a 2 by 2. B would also be a 2 by 2. Okay, so here they want us to take A plus B. We can do that because the dimensions of A and B are the same. So I take A, 0, 1, negative 4, 7. And I'm going to add that to B, negative 5, 1, 0, 2. Your sum, you just add the numbers that are in the same location. So 0 and negative 5 are both in the upper left. So if I take 0 plus negative 5, I get a negative 5. Okay, 1 plus 1, they're in the upper right. 1 plus 1 is 2, so that's your new upper right. Negative 4 plus 0. Negative 4 plus 0 is negative 4. 7 plus 2 is 9. That's it. Okay, this matrix is the sum of the A and the B matrix. Okay, now the next one, they want us to take D minus C. Well, in order to do that, you have to make sure that you have the same dimensions. So D is a 1, 2, 3 by 2. C is a 1, 2, 3 by 2. Okay, so we can do this. You're subtracting, so we have to make sure that we get this in the right order. They want D first. Negative 2, 2 is on the top. Negative 5, 1, 3, and 0. Minus C. Now C is 1, 8, 4, 0, negative 6, negative 2. So now what I'm going to do is, just like adding, you take the numbers that are in the same location and we have to subtract them. So negative 2 minus 1 more, that's a negative 3. 2 minus 8, that's a negative 6. Negative 5 minus 4 more is a negative 9. 1 minus 0 is a 1. Bottom row. 3 minus a negative 6. Remember, anytime you minus a negative, you're actually adding. So this is 3 plus 6, that's a 9. 0 minus a negative. Again, minusing a negative, you add. So 0 plus 2 is 2. So here is the difference of D and C. Okay, now here's another idea. Matrix scalar multiplication. You can multiply a matrix by a scalar. A scalar is a single number that would go into the matrix. Okay, it is just like distributing. So when you do this, you have to multiply each entry. So every single value has to be multiplied by that scalar. So here I want to take 4 times matrix A plus 2 times matrix B. When you're doing multiple operations like we are here, you have to use the order of operations. You would multiply before you would add. So I am taking 4 times matrix A, 0, 1, negative 4, 7. Plus I'm taking 2 times matrix B, negative 5, 1, 0, 2. Okay, that's what this actually looks like. So we multiply first. This 4, it's just like you're distributing. It goes to everything. 4 times 0 is 0. 4 times 1 is 4. 4 times negative 4 is negative 16. 4 times 7 is 28. Plus, now here I take a 2 and I bring it into everything. 2 times negative 5 is negative 10. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 2 is 4. So I did the multiplying. Now we add. So you take the numbers that are in the same location. 0 plus negative 10 is negative 10. 4 plus negative 2 is positive 2. Negative 16 plus 0 is negative 16. 28 plus 4 is 32. Kind of fun, right? This is not so bad. Okay, the next one. This is a scalar. This means that they want you to multiply matrix E by 1/4. So I am taking 1/4 and I bring it into every term of E. E is 8, 1, 0, -4. So I just have to multiply every entry by 1/4. 8 times 1/4 is 2. 1 times 1/4 is 1/4. 0 times 1/4 is 0. -4 times 1/4 is -1. Done. That's your final answer. Okay, now the next one, they want us to take A plus E. Remember that in order to add or subtract, you have to have the same dimensions. A is a 2 by 2. E is a 1, 2, 3, 4 by 1. I cannot add A and E together because A is a 2 by 2, E is a 4 by 1. So this is undefined. There is no defined sum for matrix A plus matrix E because they do not have the same dimensions, okay? Now, sometimes they're going to give you stuff like this where it looks actually pretty darn intense, okay? Before you start, make sure that if they want you to add or subtract anything, that at the end you would end up with something that is the same dimensions. Otherwise, you're going to do a whole lot of work for nothing. So here, if I take 3 times A and I subtract B, this piece, I would end up with a 2 by 2 because I'm subtracting two matrices that give me a 2 by 2. Your result is a 2 by 2. Now here, if I take C times 1/2, D times 4, and I add them, I'm going to end up with a 3 by 2. So I could do this step because both A and B are 2 by 2s, but the result is going to be a 2 by 2. I can do this step because both C and D are 3 by 2s. But again, my result is going to be a 3 by 2. The last thing they want us to do is add those. Well, this would be undefined as well because I cannot add a 2 by 2 with a 3 by 2 because they do not have the same dimensions. So it's important to realize that even when you have lots of different steps, kind of try to look ahead and make sure that you can do the final step. If you cannot, don't waste your time doing all the little steps along the way because that thing's not defined in the first place. All right, let's keep on looking. Now here, to me, this is when it gets really fun. Okay, this kind of feels like a puzzle, and this is where you're doing what's called matrix multiplication. In order to do matrix multiplication, when you write out the dimensions, the middle two terms have to match, okay? And this is what I'm gonna go ahead and show you how this works. So A is a 1, 2, 3 by 2. Okay, so that's what A is. B is a 2 by 2. So if you are going to find AB, you take the dimensions of A next to the dimensions of B. The middle two numbers have to match. They do. So yes, there is a product. To figure out the solution, the size of the solution, the dimensions are the numbers that are on the end. So the middle has to match your dimensions. When you multiply them, you are going to get a 3 by 2. Okay, so if I were setting this up, I could go down horizontally 3 times and vertically 2. So it'd be 1, 2, 3 by 2. This is what the size of the solution, the product, is going to be. Okay, now this is cool. So you use the first matrix and you use the rows and you multiply them by the column of the second matrix. So if I want to know this value, this is row 1, column 1. I have to multiply row 1 by column 1. So you multiply the numbers. -1 times -3 is a +3. Plus, I shift over and I shift down. 3 times -4 is a -12. When I add those together, that's my row 1, column 1. +3 plus a -12 is -9. Now I still have a number on top, so I'm staying with row 1, but I need column 2. Multiply. -1 times 2 is -2. Plus, now I shift over, shift down. 3 times 1 is 3. Add those, and that is what you get for row 2 or row 1, column 2. -2 plus 3 is 1. So now I'm done with the top row. So now for matrix A, now I go to the second row, but I need to go back to the first column so I can go ahead and get this value. 4 times negative 3 is negative 12, plus, shift over, shift down. Negative 2 times negative 4 is positive 8. Add those. Negative 12 plus 8 is negative 4. I need to stay with row 2 for matrix A because I don't have all the values for the second row. Now I need to take the second row and the second column. 4 times 2 is 8, plus negative 2 times 1 is negative 2. 8 plus a negative 2 is 6. Now I'm done with the second row, and I go down to the third row, but back to the first column. 5 times negative 3 is negative 15, plus, shift over, shift down. 0 times negative 4 is 0. Negative 15 plus 0 is negative 15. Last number, it's row 2, column 2. 5 times 2 is 10, plus, shift over, shift down. 0 times 1 is 0. 10 plus 0 is 10. Here is your product. Okay, so again, to me, this kind of feels like a puzzle, like the whole shifting over, shifting down, adding. I think it's kind of fun. Does it take a little bit to get used to? Absolutely, okay? So let's go ahead and look at this one. E, F. So you have to state the dimensions. E is a 2 by 2. Put it next to F. F is also a 2 by 2. The middle two numbers match. Okay, if the middle two numbers match, yes, you can find the product. If the middle two numbers do not match, then it's undefined. Okay, the middle two numbers match. Your solution is going to be whatever the values were on the outside. So your solution is going to be a 2 by 2. So I can go down horizontally 2 times and vertically. So this is like, I call it the skeleton of what my solution is going to be. I need to find 4 answers. Now you take the row for the first matrix and the column for the second. Okay, you multiply. 3 times negative 1 is negative 3, plus, shift over, shift down. 4 times 0 is 0. Add them together. I used row 1, column 1, so this sum goes in the location row 1, column 1. Negative 3 plus 0 is negative 3. I stay at the top until I have all the numbers, so now I shift over to the second column. 3 times 2 is 6, plus, shift over, shift down. 4 times 1 is 4. Add. This is going to be row 1, column 2. 6 plus 4 is 10. Okay, now I'm done with the top row, so in E I go to the second row. Negative 2 times negative 1 is positive 2, plus, shift over, shift down. 5 times 0 is 0. 2 plus 0 is 2. Last number, it's second row, second column. Negative 2 times 2 is negative 4, plus 5 times 1 is 5. Negative 4 plus 5 is 1. That is your product. Okay, they want us to use these two to find the product of BC, then find CB. Okay, so BC is first. So B is 2, because there's 2 horizontal rows by 1, 2, 3. So this is a 2 by 3. C is a 1, 2, 3 by 1, 2, 3. Okay, so they want us to multiply a 2 by 3 by a 3 by 3. The middle two numbers match. So yes, there is a product. Your solution is going to be a 2 by 3. So it's going to look like this. Horizontally, I would have 2, but vertically, I would have 3. 2 rows, 3 columns. Okay, so now when I go ahead to multiply this time I have 3 numbers, but it's the same idea. So if I want this value, this is row 1, column 1, you multiply. 1 times negative 2 is negative 2, plus, shift over, shift down. 0 times 1 is 0, plus, shift over, shift down. 3 times negative 1 is negative 3. Now that I've gone through all the numbers, find the sum. That's what goes in row 1, column 1. Negative 2 plus 0 plus negative 3, that's negative 5. I still have values to find in row 1, so I'm staying here. I'm just going over to the second column. 1 times 4 is 4, plus 0 times 0 is 0, plus 3 times 1 is 3. Add them together. 4 plus 0 plus 3 is 7. Stay at the top, but go to the third column. 1 times 2 is 2, plus 0 times 0 is 0, plus 3 times negative 1 is negative 3. 2 plus 0 plus negative 3 is negative 1. I'm done with the top row, so now I go to the second row and back to column 1. 2 times negative 2 is negative 4, plus 1 times negative 1 is negative 1, plus negative 2 times negative 1 is positive 2. Add those together. Negative 4 plus a negative 1 makes negative 5, plus 2, that's negative 3. Now I go to the second column. 2 times 4 is 8, plus negative 1 times 0 is 0, plus negative 2 times 1 is negative 2. 8 plus 0 plus negative 2 is 6. Last number, it's the bottom row and the last column. 2 times 2 is 4, plus negative 1 times 0 is 0, plus negative 2 times negative 1 is 2. 4 plus 0 plus 2 is 6. So this is the product of B times C. Now, if I'm going to find C, then B, you have to write out the dimensions in the order that they want. They want C first. C is a 3 by 3. Okay, so this is C, then B. 1, 2, 3 by 1, 2, 3. B is 1, 2 by 3. 3 and 2, because the middle two numbers match, this is undefined. And what they're showing you here is typically when you are multiplying, you have that commutative property that says you can multiply in any order. That does not work with matrices. Okay, if I take B times C, I can do it and I get a new matrix. If I just go ahead and flip the order, this is undefined. So the commutative property for multiplication does not carry over for matrices. Your assignment for 7.5 is to complete a worksheet where you will practice adding, subtracting, using scalars to do multiplication, finding a product. And again, anytime that they give you more than one step, please make sure that you follow the order of operations. I hope you guys enjoyed doing matrix operations, and I'll talk to you soon.